This is a demo video to show the result of my final project in general computing on graphic hardwares. So in this video, I will show what kind of things I do. I use Xcode, Objective-C, and C, as well as OpenCL and OpenGL to create this project.
Build started.
Now I run my project. In this project, my main idea of this project is create a graph. I randomly create a graph and find the shortest path by both GPU and CPU based on the Floyd Warshall algorithm. So firstly, I will automatically randomly create a graph. So here the number of nodes I entered, it means there are 10 nodes in this graph. And firstly, I use CPU to initialize the nodes like this. So we can see here is a graph. Each pairs are connected to each other. So now we spend the CPU time is like this. And if I use GPU to initialize this, it's like this. So here we can see the GPU time is more than CPU time we created this project. But this is based on the small number of the nodes. So now I create 100 nodes in this graph and see what will happen. So here we can see the CPU time is 400 and 602. So now I use GPU to do the things. So we can see about 100 nodes, the result of the GPU, the time of the GPU is half time of the CPU. But in this graph, we cannot use this graph, so we need to change the distance between each point. So here I change the distance. For example, I change the distance to 2, the offset is 1, and we draw. So this is the new graph. This graph is based on the nodes that created by GPU or CPU. But this graph is not a connection graph, so we need to change the parameters of the graph and make this graph as a connect graph. So here we can see this is a connect graph, but the connection, there are many connections, so we need to reduce this connection in order to find a short path. So here I still draw. So maybe like this. I think this is a graph. So now what we do is I select a start index. This is node index. For example, I choose 1, and then I choose 71, and then here I click CPU calculate the path. So what will happen? So here the white lines is the shortest path calculated by CPU. In CPU it costs 0.01957 seconds. So this is use CPU to do the things, but there is a problem for GPU like this. So here I click GPU, and it will have some troubles in the memory, but now I still check the problems here, but I don't know what happened. So later I can use some small now I restart this application.
Build started.
Now I use small number of the nodes and see what will happen. So here is 10 nodes. Now I change the offset like this. Oh no, this is not a connection graph. So here maybe 10, 2, 3. So in order to create a connection graph, we need to control and modify the parameters here. After that, and I choose okay 0 and maybe 7, and now I use GPU. First I use CPU to calculate the path. So here is the path, the shortest path from the node 0 to the node 7, and now I use CPU to calculate this result. So here we get a result like this. What I have done is while here I cannot here. Okay, why now I cannot draw a path in this graph by GPU? Because there is a problem. I still try to fix it. This problem is like this. So now I need to go back to the slides. As we talked about before in the slides, okay, this is what is new in my. This is the previous work, and okay, this one. So this is my algorithm to find the shortest path based on the Floyd Warshall algorithm. First, I count the levels of all the vertices. So here we can see in my project. So here I counted the level. So here there is just one levels in this this graph. This one I calculate by this function. Okay, which function? This is CPU and see. Okay, this is GPU. First, I calculate the levels from index and from a start index and end index. So what I have done is based like this. So I go through all the nodes and find this is the first level, this is the second level, this is the third level, and this is the fourth level. So I based on this formulas, I find the level here in this graph. So this is correct in my project. And then I use group to give the group of these levels. Actually, I define two groups. So first, I split this graph. This is left half, this is right half. So if I use two groups, so this is a group and this is a group. But in this graph, I just have one levels. So I just have one groups here. But now maybe I can change some parameters, and then we can have two levels like this, and maybe select 8. So this one, okay, and level, okay, because some maybe I can change to 20 and change this to 8, and I draw this graph, and I this one 0.5. Okay, and then I choose this one. So first I use GPU to find the shortest path and see where is the point. So we need to find a long, okay, this one. This is a long distance, and then I use GPU. So here we can see I calculate 2 levels. Here is, oh no, 3 levels. There are 3 levels in this graph. 3 levels, and now I divide these 3 levels in 2 groups. So what is I see is like this graph. I divide that graph in these 2 groups. And then what I do is through this group, each group into the GPU, and use GPU to do the Floyd Warshall algorithm and recalculate the vertex by this code. by this code. So this is GPU code, GPU kernel function. First, I clear all of the group index, and then clear all of the group vertex values. And after I finish that, I use local shared memory to create a new matrix in like this. So here is the new matrix. This is a new matrix. This is a new matrix, and the blue one is a new matrix. Now I need to calculate the new matrix. So here we can see this is I define the matrix, and this one is the small values of the new matrix. But now I cannot use this one because there are some conflict between each group. So now I try my best to find out how to combine the group. That's the reason why I cannot draw the graph. Here. So here I can use GPU to draw this line, but I cannot use a CPU to draw this line, but I cannot use GPU to do the things because the GPU because I divide each group. How can I connect each group? It's a headache things for me, and so here I just judge whether this vertex is in this group. And here I use shared memory and recombine the original value. That is to see in order to create this matrix. This matrix original value is based on this graph. So I need to load this graph value to GPU and then do Floyd Warshall algorithm. So that's why here I load the value in here and use this one to calculate the Floyd Warshall algorithm here. After that, I write this result back to the output, and then I want to reuse these values. But there is a problem because two groups contain the same vertex, some of the same vertex. If I write this back to the matrix, it will rewrite some other group's value. So this is a problem I try to fix it, but now I still find nothing to deal with this problem. So here we can see the matrix I print from the shader, the kernel functions. First, this level I show, and this matrix, this matrix is based on the vertex here. So this matrix is the new matrix I use GPU to create. After that, I load each of the value into here, and then I use this algorithm, Floyd algorithm, to recalculate this value here. So this is what I have to, because there are two groups, so we can see these two groups here. There are two groups. This is the first one, and I think there will be another one. Oh, where? Oh, okay, maybe in another position, but I think it will have two groups here. Yes, two groups. Let me see. Okay, this is okay. I think this will be the two groups. So, but now there are still some tricky things. I finish. Okay, let's go back to here. This is calculate level. Okay, now I can correctly calculate the levels, and now I can correctly calculate the group. now I can use GPU to get the shortest path in each group. So we can see in each group. In each group. So here I use GPU to calculate each group. But there is a problem here. Is after I calculate the each group shortest path, but I have no idea how to combine each group values. So that is to see here. This is levels number, and okay, so that is to see this step 4. I have some problems, so that's why I cannot fix these problems in this project and use this one and calculate this shortest path in this graph. And then in order to analyze this data and the graphs, so I offer save image to, so here I save the image to this place, and I can combine some data. So here not combine, just to analyze some data for the later use. Here I can save matrix to the desktop. So here we can see this is the matrix. This matrix is based on this graph. So this matrix I can use to analyze this graph. And this is the vertex. This is the vertex index. This vertex index is created by GPU. So in this final project, I use GPU to randomly create these graphs. Also, I use GPU to do some of the Floyd Warshall algorithm, but the final function I don't finish it because it is very tricky. So now I will explain what is the tricky things. So here I'll use this one to calculate and do something, but there is a problem things is in this graph. So here I am find some troubles. For example, if there are two same vertex in that place, so how can I combine the shortest path in these two, and this one and this one? Also, I meet some problems in here. Because this is a simple graph, so I can easily use this graph to explain the flow. But in my project, in this project, it is very complicated. This complicated is more than here, so sometimes it will find some troubles in this place. Okay, this is what I have done in my final project. Now I will try to use 1000 and to show the difference. So here I give 1, 2 and draw. Okay, this is 1000 nodes, and here CPU use this time to draw this graph, and GPU just use half of the time to draw this graph. But here I also can use CPU to calculate the different vertex position. Okay, here, but it will cost approximately 16 seconds to calculate the path, because I use function recursion to find the path. Okay, so there is some problem. Okay, maybe this problem is based on the previous memory free. So here I will recalculate this again. So here is 2, here is 1. This, okay. Why there is like this? Because the row and column max number is smaller than the number of nodes. So here I just change this one. And now we can get graphs, and then I select some points and nodes and find the shortest way to see which path is what we need. So here I use function recursive to find the shortest path in this graph. it will cost too much time. And also so here we can see this is path, the shortest path from the 1 to the 600 nodes. Okay, this is what I want to explain in this project. Also, I have questions. Is like this. Because I cannot use function recursive to find the shortest path in the kernel function. So now I need to find some other ways to find the shortest path and save the value. So now I face two problems. One is how to use function recursive to instead of to use in the kernel function, and the other is how to compile the result of each group. This is each group. So after I calculate get a result from this one, and how can I calculate them? Okay, this is the project that I do in my final project. Thank you.